Good afternoon, everyone. My name is Mark Dirks, and on behalf of ACRL and Choice, I'd like to welcome you to today's program, Exploring Data Visualization Approaches to Enhance Student Engagement, which is sponsored by McGraw-Hill. Today's discussion is one in a series of sponsored webinars from ACRL and Choice that addresses new ideas, developments, and products of interest to the academic library community. Free to users, these structured 60-minute live presentations provide the opportunity for interactive discussions of important new issues and developments in academic librarianship by librarians, vendors, authors, and other interested stakeholders. Before we get started, I'd like to point out a few features of the webinar software. In the main area of the screen, you can follow along with the presentation materials. Along the right-hand side, you will see a Q&A panel and a chat panel. If you don't, you can click the buttons labeled Chat and Q&A in the upper right corner of the screen to activate the panels. Please use the Q&A panel to submit questions to our speaker. At the end of the presentation, he will take a few minutes to answer your questions, so please do send them in throughout. If you experience any technical issues, please use the chat panel to let me know, and I'll troubleshoot the issue with you privately. Today, we're using the hashtag ACRLChoiceWebinars. So if you've got another screen handy, shout out to us. We're at choice_reviews on Twitter. Also note that we're recording today's program, and everyone who registered will receive a follow-up email with a link to the archived version. Our presenter today is Dr. Anselm Spoerri. Dr. Spoerri has a PhD from MIT and is a faculty member at the School of Communication and Information at Rutgers University. He has conducted research in the field of information visualization for the last 20 years, and a recent co-authored paper on visualizing what is most controversial in Wikipedia received widespread media attention with articles in Wired, MIT Technology Review, The Washington Post, and The Economist. Dr. Spoerri leveraged his data visualization expertise to guide the visual display and interactive functionality that are key to AccessEngineering's DataViz. And with that, we're ready to get started. So over to you, Dr. Spoerri.
All right, excellent. Just double check, you can see the PowerPoint slides, the beginning of it.
Yes, we can.
Excellent, thank you so much. Just need to do something on my end. Perfect. So, as mentioned, I work and teach at Rutgers. I do research there as well, and I educate or teach a lot of librarians in the information visualization course. So, as mentioned, it's all about talking how can we explore data visualization approaches to enhance student engagement. So when talking about engagement, it's about attention. How can you grab the student's attention? How can you stimulate their curiosity and also tap into their passions? Visualization is well designed if it draws the viewer's attention to the meaningful data patterns. So that's the name of the game. What can we use to help the viewers see what we think is important? We can use contrast. We can use size differences. We can use color differences. We can decide to place things in different locations and therefore guide the eye. Or we can use motion cues to draw the eye. Further, we can tap into our natural ability to see similarity between visual features and group them. We can use the proximity principles that the visual system is excellent at using in order to make sense of what it sees. We can use or feed the continuity principle. So if something is placed on a continuous line, the visual system will notice that and hone in on it. We can use containment by putting bounding boxes around related items, and we can connect things with lines in order to show a relationship. So this is, in a way, our basic toolkits, or what we have in our toolbox in terms of visual features and visual design that we can do in order to draw the viewer's attention. Key is we need to make sure that we use the right data display to make the data patterns visible. So I think if there's one thing that I would like to take away, that you take away from this talk, is think about what are the patterns in the data, and am I selecting the right display to make those patterns visible. Now, further talking about engagement, it's about passion. and how can we tap into students' passions, the viewers' passions. And there we need to talk about or visualize data that matters. It needs to be representative. It needs to be relevant. It needs to be rich in terms of the number of data points and the data variables that we can explore. And we need to accurately represent it so that the visual representations that we use do not distort the data. And further, we want to have trusted and rich data sources that we are drawing from. Now, when it comes to designing visual displays, there's a tension between function, decoration, and emotion, so to speak. They're not mutually exclusive, but it's a balancing act. So we have, on the one hand, we want to foster engagement, and we might add things to the display to make it more accessible, more entertaining, but we can run the risk that we are chunking it up. We're putting chart chunk in the display and therefore sort of get in the way of the message or dilute the message. We can support functions so that we can reason with the data. We can make inferences that are accurate. We can repeat them. It's not like, oh, this time I saw it this way. The next time I now look at the data in the visualization, it looks different, so I don't know what I should think or what the conclusion is, versus promoting entertainment. But these are tensions that designers have to sort of straddle when they're designing visual displays. So I thought a good example to look at is Road to School, visualization created to show the number of Syrian children without education because of the war. Here's the data, the cold facts. 2011, almost 400,000 children were without education. Go to 2016, almost 3 million are without education. I could visualize it using a bar chart, using a strong red color to draw your eye. And you're seeing it's growing. Looks linear. It's increasing. Now, there's another way that you could visualize it. And what's happening here is, and this is not something that I've developed, it's developed by Interactive Things, each word represents 10,000 Syrian children. So let's look at it. So here we are. We have on the left some explanatory text, and again, each of the words are 10,000 Syrian children. And as we start scrolling down the page, time starts to emerge, 2011, and as we keep scrolling, suddenly we will see some of the words start dropping to the ground. And here we have a number that's telling us more than 500,000 of children don't have access or are denied education. If we keep scrolling, more and more of the words are dropping to the ground, so to speak. And if we keep going, the number increases, the same data we saw before. But as I was watching this, and I would say I'm a seasoned data visualization person, or you could call me jaded, I had a reaction, I had an emotion. Something got through and connected to me in a way where I could feel the data. It said something to me, and I would say there was a certain sadness that it brought forth in me, and also empathy that I started to feel towards what's happening. Whereas if I just looked at the bar chart, yeah, looks large numbers, but that's that. So this visualization, at least for me, is able to instill or elicit an emotion and make the data become more meaningful as I interact with the data visualization. Now, this is a balancing act. For some audiences, this works, for somebody else. But here I would say this is a good use of taking some simple data and then finding interactive animated effects in order to elicit an emotion in the viewer. Next, data. Data is messy. Any of you have ever worked with a data set or tried to visualize it, you spend a huge amount of time just trying to get the data in the form that you need it. You need to wrangle with it, and you might even have data wrangler specialists on your team. You have to clean it. You have to make sure it's consistent. You have no holes in it. There's not any outliers that don't make sense. You have to organize it to put it in the form so that you can visualize it with the tool you had you think would be the most promising one. And so getting the data in the shape to be visualized is half the battle. So it's not about so much about visualizing it, it's getting the data there. Now, once you've done that, the question is, are there any meaningful patterns in the data? For that, you need to explore it. You need to look at different ways of looking at the data in order to see, yes, you may have had an idea that's what's important or that's what's going on with the data, and maybe that is the case or maybe not. So you have to sort of switch around and pivot in order to find the right display to see what's there. The other thing you need to consider is what you want your audience to be able to do with the visualization. What kinds of tasks should they be able to perform? And what do you want them to infer about the data? And then again, it's critical that you pick the right data display to make the data patterns that are there visible. So, no data patterns, no story. No story, no engagement. So it really hinges all on making the patterns in the data visible with the appropriate choice of visualization. Now, I would say there are sort of workhorses in data visualization, the ones that are used most of the time. But one considered standard data displays. We have bar charts, we have line charts, we have pie charts, we have bubble charts, we have scatter plots, we have maps. And so these are what you will use most of the time, or let's say 80% of the time, in order to visualize your data, and they're good enough. They can do a lot if they're used appropriately. So to echo again, select the right data display to make the data patterns visible. Now, if I were to tell you, there's a way that we could rank visual features, and some of them allow you to make more accurate inferences about the data, and others, yeah, you can make some qualitative inferences, but they're not super accurate. All right. So at the top, we have position. That's in a way our most prized possession in terms of where we put something in the display, because this is something the human visual system is extremely good at being able to tell two dots are close together, so together, or far apart, or yes, they are the same, not the same. We can make very fine distinctions very accurately. Next up, we have length differences. We are good at telling whether two bars are the same length, double the length, 3 times the length, and so on. Then next, not as accurate, is the difference in slope of lines, their orientation. We can make some inferences, not as good as length, not as good as position, but decent. Then we have differences in area. Oh, this looks like a big circle, this looks like a medium circle, this looks like a small circle. And then differences in volume representations. It's even less accurate than being able to compare two areas. And then at the bottom of the hierarchy or the ranking is differences in color and differences in shading or saturation level, let's say in a specific color. This is the least accurate. It gives you a qualitative sense. And so you may read or hear, yes, we can make distinctions between millions of colors, meaning I give you 2 colors and ask you, are they the same? You can distinguish between millions. But if I put multiple colors at the same time, once I reach 7 or so, we're topping out. All the others that you're adding in our array, adding visual noise. You can't make those distinctions effectively. So color loses its power. So it's good for categorical data, so making sort of 5 to 7 distinctions at the same time. Now the question is, how does this ranking of visual features relate to our standard or workhorses in data visualization? At the top, are scatter plots. They truly make use of where they place things. And if the dots happen to line up on a continuously changing line, the visual system will notice that immediately, because one way the visual system is able to make sense of our visual world is it makes assumptions. And one of the assumptions is that certain things are organized or are smoothly changing, and uses that in order to infer, based on what it sees, what it's looking at. So the scatter plots really taps into that ability to see differences in position. Then we have the bar chart that taps into our ability to see differences in length. The line chart, differences in slope, how things are changing abruptly, slowly, linearly. And you may be surprised to see that the pie chart also taps into our ability to see differences in angle. You may say, no, this is about area. I could shrink this pie chart to very small, and the relationship between the parts is still the same, and you will be able to infer it. So although it looks as if it's about area, it's actually about angle. Next, we have bubble charts. They're tapping into differences in size of areas. But as you can see, bubble charts are a way to display data, but they are not as powerful, I would say, or as accurate as, let's say, being able to use a scatter plot or a bar chart or a line chart. And then we have maps, and there you often see the use of color and of color density or saturation levels to make distinctions in a data variable. And as mentioned, you can maybe 5 to 7 steps of differentiation that you can make, but not more. So it gives you a qualitative sense about what's going on. So I hope this will help you when you next ask yourself, so how could I visualize this data, which to be mindful of the strengths of the standard types of visualizations and what visual features that they are making use of in order to communicate the data. Now, one of my favorite examples for what I would say, we have the standard displays, and then we have very esoteric, very novel, very innovative new displays. Sort of a step along the way is the motion chart. It started out as Gapminder. It was developed by Hans Rosling, who unfortunately died a few weeks ago. And then it was acquired or incorporated by Google. By the way, if you're hearing some sirens, New York City says hello. And so what you have here at the core of it is a scatter plot. And then you're seeing different sized circles that are visualizing a third variable. Here, population. Color is about where in the world it is, which continent. And then we'll see in a second how it moves over time is the fifth data variable. So I would say this is a souped up scatter plot, and let's look at some fertility data. And here, this is data that's made available via public data from Google. And what are we looking at? We have in the horizontal direction life expectancy, and in the vertical direction we have fertility. And the question is there a relationship between those two variables? And looking at the data from 1960, it seems as life expectancy increases, fertility rate drops. So there's an inverse relationship. The dots are not perfectly on a line or on a smooth course, but there's some structure to how they're spatially positioned. And the visual system is very good at being able to detect that and to reason with it. Now, if I start playing the time element or bringing the time element into it, what you will see is that the dots are moving in an orderly fashion. Like a flock of birds, they're moving together, not all the same, but overall in the same directions. There's some that are scooting off to the side, and we'll look at them in a second. But there's an overall trend towards greater life expectancy, and in parallel, a fertility rate is dropping. And from here, it's just interesting to see those that are below 2. Those are nations that are in danger of dying out because there's not enough offspring being produced in order to replace those that are dying. Now, if I play it back, what we can see here, now notice here some outliers. This is shooting out, and if you go there, we see Rwanda in 1992. What happened there with the genocide? There was a drop in life expectancy, and the human visual system is able to see the overall orderly motion and also be able to accommodate for outliers, like here, where we have Cambodia in 1975 with the war there, and where there was a drop in life expectancy. So for me, the motion chart is a beautiful example. If the right structure is in the data, meaning both a relationship between the two variables that you're comparing, and there's a temporal trend, the motion chart will make it visible, and the visual system will lap it up. It will see it, it will hone into it, it will detect it, and it can even handle outliers. So consider that in the future where you want to visualize up to 5 data variables, there's this possibility using this type of display to make it happen. But you need temporal data and you need a correlation or relationship between 2 variables. Here, just a screenshot of what we've just looked at. Now, when we're talking about contemporary or modern data visualization, there's some key design principles that are meant to take us from our standard displays one step up so that we can deal with larger data sets, larger number of data variables. One is interactivity. So as the user interacts with some controls, the display immediately updates, and this is very important for the motion perception system, because if the changes in visual information rapidly enough, then the visual system is able to infer things based on how things are changing. Then we have the concept of linked displays so that we can go beyond, let's say, 5 data variables that we can explore at the same time. So let's look at an example here, stacked scatter plots, and here we're looking at pairwise comparisons or pairwise scatter plots. And when I start to select, let's say, these dots here that seem spatially clustered, I can ask myself, well, look, are they equally clustered in other scatter plots that are looking at subsets of the data space? And I can see, for example, up here, that there's a wider spread in terms of how these data dots are placed in that display, and that might give me some information, some insight into the data. But the key thing here is I have multiple displays, and they're linked. And this allows me to go from 3 to 4 to 5 and more data variables that way by having this linked component or linkness between the displays. Next, we have overview. Show me all the data. Give me one big picture so I can get sort of a sense of the lay of the land, and then I can start zooming and filtering in order to find those things that I find interesting. And then when I found a few things, then I might get details on demand that gives me more specific information about what I'm looking at. So there the challenge is how to come up with representations that allow you to see it all. Then we have the concept of dynamic queries. And what that means is when you are telling, look, I'm interested in a certain range of values, we want to, and that's in a way a query, that the visualization lets us do that graphically, visually, and automatically updates. So here's an example of parallel coordinates, which are just sort of going into a realm of displays that are less familiar, less standard. And you may say, hey, this looks like a lot of spaghetti, lots of stuff. What's going on here is we have, let me count it off, 7 data variables that we're visualizing side by side, and an endpoint here gets translated into these straight line segments. What I want to highlight is if I say, look, here I want to look at only these values, then I'm creating a dynamic query, and it shows me how it plays out across the other data dimensions. And if I now take this window and move it, and if I go very high, I can see they're more tightly bundled together. And as I'm moving down, there's much more spread, and then it's all over the place. So maybe here I can start honing in on some interesting relationships between the variables. Now, one thing to keep in mind in data visualization, if this is not an important data set to the person exploring it, they will not be motivated to learn what it takes to read, let's say, parallel coordinates. But if they have something, there's a burning interest, then they will make the effort in order to learn how to interpret very specific visual patterns in that visual representation. It happens to be the case that parallel coordinates will exhibit very specific visual patterns depending on the structure in the data. Next, we have focus and context. So you have a large data space, you want to zoom in, and you don't want to get lost and say, I don't know how many of you have explored image in Photoshop, you zoom all the way in, you start messing with it or editing it, and then you say, wait a minute, how does it connect to the whole thing? And then you have to zoom all the way back out. So one principle that has been implemented or can be implemented is what's called a fisheye distortion. So here we are looking at a network, and as I'm moving my mouse and I'm coming to these dots, they're the purple ones that are closely together, and I want to see them in more detail. I can just magnify that area without losing sense of the whole. So I have focus and context at the same time. And so this can be sometimes very important as we're doing data exploration. Then animating transition. That's critical because it's feeding the motion system. The motion system makes sense about the structure of things based on how things are moving. It's amazing. And so if we can feed it, then it will allow the viewer to make more powerful inferences and also much more quickly assimilate the changes in the display. So let me look here. We looked at the motion chart that makes use of animation. Let's look here now at the visualization of a budget using bubble charts. And let me just scroll to it. So here we have it. So color coding in terms of how much it's changing from one year to the next. But what I want to highlight is if I want to now visualize it in terms of types of spending, notice as I click here, the transition is animated. So I can track as all these circles are moving into different locations. I can't track each of them, but I get a sort of a sense how the change is occurring, and it makes it much easier for me to now start to reason with it, to simulate what just happened. If I were to now visualize it like this, again, we can sort of follow along and therefore much more quickly enter the visualization because we had animation support. Finally, the name of the game is increase information density. And sort of tongue-in-cheek, what I like to say, leave no pixel behind. We want to use every pixel on the screen so to be able to put data there. And so one example of that is the tree map, a way to visualize hierarchical data. And what we'll see in a second is all the files in a hard disk. And these are over 1 million files. And the size of the rectangles is proportional to the file size. The color represents a different file type. And you may see these white lines, boxes within boxes, that shows you the folder hierarchy. So you can visualize this way any hierarchy with 50 levels, 10 levels, 100 levels, and as many items as there are, and it gives you the big picture, the overview, and then you can start interacting with filters and zooming in order to hone in on a certain part that you want to know more about. So the tree map, it's a more novel or newer visualization that is slowly entering sort of the mainstream, I would say. We're starting to join the toolkit of not standard, but more common visualizations that are being used, or visualizations that are more commonly used. Let me now look at another example to illustrate some of the principles. And here we have what The Guardian created, a visualization of gun violence in the US. It's a recent visualization. Here it's using the map as the representation because it's about spatial patterns. And do we see spatial clustering? And we can see here some hotspots. And what I would like to highlight, and let me go to the web page directly. It will take a little moment to load. If I click it, let me click it again. Yes, there we go. So here is our map that we've just looked at. So we can see the hotspots for gun violence in the US. And what I wanted to highlight is here the case study in St. Louis. So here we see the outline of St. Louis. And in a second, it shows us these are the incidents of gun violence or homicides, gun homicides in 2015. And if they were randomly distributed, there was no structure to these dots. That's what it would look like. But actually, this is what the data looks like. And here, a very nice use of animation. We can see how now these dots are actually going to their position where this event, a gun violence, occurred. And we can see there's a clear spatial clustering. And now the next question that comes up, so how does that relate to that specific neighborhood? Is there anything special about that neighborhood or that part of the city? So if we start to plot using color differences or saturation, where we have higher degrees of poverty, we can see that the homicides tend to cluster in areas that have higher levels of poverty. If we were to ask ourselves, what about education, where there's a higher degree of not having a high school degree, we can see it's also some correlation or relationship between not having a high school degree and where gun violence occurs. And finally, if we show race percentage of people that are black in that specific part of the city, there's an even clearer visual pattern. And the visual system, it's like, whoa, all these dark areas all together, that's a visual event that it will notice. And there's structure in the data, and the map is well chosen to make that structure visible. We'll now go quickly through what I just showed. Whoops, wrong click. Let me go back here. We'll speed through it. Here now we don't have the benefit of animation. We have smooth dissolves, and sort of you can see how animation adds to helping to comprehend the data. Now the next thing I want to talk about is we have different types of data and different visualization approaches. So we have simple data, we have curated data that can be large, but a lot of effort went into presenting it, preparing it. And then we have general data that may be so large that you can't humanly all curate it, so to speak. Then we have simple visualizations, custom visualizations that are built on the top of the standard displays. And then we have general purpose visualization that is sort of everything under the sun. And let's look at some of the specific groupings. So I would say when we talk about simple visualizations and simple data, this is a good use, or their infographics is excellent. Okay. There you may have had a designer, a team that has identified the key data patterns and uses familiar visualizations in order to get the highlights communicated. So here an early example of infographics where it's about how many people are working at home and creating cloth. This is from 1920 all the way to, sorry, not 1820 to 1880 in England. And at its core, this is a stacked bar chart. But by using human figures, pictograms, it makes it more relatable. So we know, aha, this is about people. And then we see an orange or reddish color with a little smokestack. Ah, this means factory workers. And then in blue, we may see, this must be the cloth that's being produced. And we see it's increasing as we have a shift away from weaving at home to weaving in factories. And we can infer that from this display. If it had been just a stacked bar chart, we would have to look at the legend, then relate it, and it wouldn't have thrown us in as easily. So that's, in a way, the power of infographics, if they're well designed. Now, if you do a search in Google Images for infographics, these are some of the results that you get. And what I would say is, whoa, it's colorful. So one of the dangers, yes, color is important. That's one way you can draw the eye, but you can overdo a good thing. And so the challenge there when designing infographics is, are you just putting something on the screen to draw the attention, but it's not really crucial or functional in terms of communicating what the data is about. So it's a balancing act. Next, we have a larger set of data. We want to be able to explore it, and for that purpose, we will use appropriate displays for the kinds of data that has been curated. So one example is the OECD. Collects a lot of data about different countries. Here, for example, about PISA, education data. And here it's using a map visualization, using color coding to tell which countries are below the standard, which ones are average, and which ones are above. Now, it looks like a colorful map. There isn't really some clear-cut spatial clustering going on. Maybe only if you look at Europe, there it's more primarily green. But it gives you an overview of all of it. Okay? So one could argue whether the map is the most effective way to visualize this data, but it's a way that people can relate to, and we think in terms of maps. We're familiar reading maps, and so this is a way to enter the data. Then you can pick a particular country. Let's say you are from Australia, you want to see how does Australia compare to Canada, and then the appropriate visualization is provided by the OECD, so you can see the trend over time. Using two colors, simple to keep them apart and be able to tell whether they're the same or not. Then we have the World Bank that also makes large amounts of data that have been curated, vetted, made sure that they're correct as best as possible, available to a large audience. And it's offering map visualization, also the motion chart where you can look at a scatter plot and animate it over time. So this has become sort of part of the repertoire of visualizations that users can use. And it's appropriate for this type of data. Then we have the Google Data Explorer that lets you explore many data variables and decide which ones you want to put on the X and Y axis. And you can also look at trends over time. And there is here the types of visualizations you can do. line charts, bar charts, maps, and scatter plots are familiar workhorses, which are in most of the instances perfectly suited to visualize, especially this kind of data, economic data. Now I want to segue over and talk about database material properties that I've been a part of developing. And here we are also working with a curated data set. A huge amount of effort went into come up with a representative set of material properties, up to 60 property variables and 200 representative materials. And the purpose is to allow students and teachers to learn about the relationships between material properties. And when they're designing, let's say, an airplane, what would be appropriate choices. So here we have, as a beginning, a way to select materials or filter them. There's a hierarchical way to do it. We've broken them down into the 5 main material properties, and you can drill down 5 levels deep and select subset as you see fit, depending on what you want to explore or better understand. Then, for this specific purpose, and remember I said earlier on, you want to ask yourself what kind of task or what kind of inference do you want the user to be able to do. So in this particular case, one thing that was established is students should be able very quickly to see the range of values. So what was done here is sort of a variation or a simplification of a scatter plot where what's called a dot plot, where the main material properties are organized in columns and they're assigned a unique color, and then we can see the spread of values. So here we have the metals, and we can see here a very high density value for gold. Then there is lead, and comparing it to ceramics and others, we see metals tend to have a larger range of density values. If you break it down between ferrous and non-ferrous, we can really see the ferrous metals are tightly packed or tightly clustered in terms of their density values, whereas non-ferrous have a much larger range of density. So immediately, as a student, you get a sense of what are we talking about when we're talking about this specific material class as it relates to density values. You may have noticed the animations when you're zooming in, zooming out are animated, and now here we can go back and see all of the major classes side by side. Next, we want to sort of drill down and see specific material subcategories. How do they play out as we interact with the controls? So if we apply a range filter and say only it has the density has to be, can't be higher than a certain number, notice those that are above the threshold are dimmed. We can deselect all of them, then they lose their black border. We can start drilling down and say, I'm interested in steels. And what you see immediately, the dots that light up, so to speak, or get a black border are close together in space. That means they must have very similar density values. Now, if I was interested in a non-ferrous metal, and let's say aluminum alloys, I see they have lower values than steels, definitely, and they're also very close together. So one inference the students can make when talking about density and aluminum alloys, they tend to have low values and very similar values. So it doesn't make that much a difference which one I pick in terms of the aluminum alloys. I will get similar density value. Now, once the student has an understanding of one material property, we can add another one into the mix, and we have linked displays side by side. And this now allows the student to sort of see how does one selection play out or in one material property out in the other. So if you look at the steels, like for density, we already knew they're very similar to values, but for elastic model, it's the same. If you bring the aluminum alloys, again, they behave similarly in terms of the range that they have. They have very tight ranges. We can mouse over certain items and we can see the related ones in the other displays because the displays are linked. And therefore, we can explore a larger data space. Now we can add even more displays. So we have 2 dot plots and a scatter plot that makes more explicit the relationship between the variables and 2 interactions. And as we're interacting, we're getting clear visual signals that then can be used in order to sort of deepen our understanding about the data. Let me just highlight some of the features. Again, all these three displays are linked. Let me just play it, make sure it's playing. There it is. We get also details on demand. We can apply a log scale. The animation is, there's an animated transition, and now we can see smaller values much more easily. We can now go in and say, look, I'm interested in specific polymers, and how do they play out? Are they spatially distributed or tightly clustered? They were not so tightly clustered, whereas if you now look in a second at natural materials, there we can see they tend to be a very similar density and elastic modulus relationships. Now, I'm not a material scientist, but by using these displays, I can start learning, building hypotheses about how these material properties relate to specific classes or material subclasses. Finally, the key thing with this tool was also, so we have all this data curated. We want to make it easy for the user to create stories about the data where they take users in a step-by-step fashion, start out easy, and bring more relevant material properties into the mix, and make it so that you can share it, build on somebody else's work, and then make customization as you see fit. So there's several case studies. So here we have an example about aerospace structures. And what you will see is there are pages at the top, a timeline or that you can scroll through. And you see here there's 4 displays. We can go to the very end where it's all being summed up. And here's sort of the punchline brought together. It's sort of the key insights, looking at the key material properties and their relationships. And again, I can drill into the data, see, so well, how does this relate to my steels? Would steels be a good choice when I'm building an airplane? And what I can see is that in terms of fracture toughness, there's quite a range of values, also in terms of expense or how much it would cost. If you look at aluminum alloys, they are lower fracture toughness, but also not as expensive as certain steels. So the student can start making these types of inferences by looking at and interacting with the visualization. We can star things, so we can sort of say, this is one of my, what if it were titanium? How would that compare to steels and aluminum alloys? I can only show the ones that I've selected, so I'm not distracted. And then at a later stage, when I want to bring other materials back in because I want to maybe include them in my selected set, they're there, and I can easily select them. Now, as mentioned above, you see these little thumbnails of the different pages. You can save it or save as, so you can take somebody else's work and then customize it, so you can take if another instructor made their material available, or students working in a team can build up presentations and then share them with each other. So what I'm trying to illustrate here, so we don't just have the visualization, oh, great, we found the variables we want. No, we can integrate it into a larger knowledge production process. Finally, what I would like also to highlight, so when you're drilling into this data, it's also important to have access to related content. Yes, you can, and let me play the video. Where is my mouse? There it is. Going to the beginning, where we're sort of starting out the story, we're talking about density. We can provide some introductory information with instructions or background information that we expect, let's say, the student to read. And we can also, towards the bottom of the display, provide access to related content. That can be any web page. So we could look at content provided by AccessEngineering, authoritative resources about airplane design, and the student can further drill into that to deepen their understanding. Or we could make access to MatWeb, which was actually a source for a lot of the data that's being visualized, and it's sort of ironic to see here, you're seeing different materials in their representative silos, whereas here now in the visualization, they're all together, and you very quickly get an overview of the range of values as it relates to density as being shown here. So that's really the power of visualization. It takes this data and makes it more easily accessible so we can see what's going on, what are the key patterns. So as it relates to material science education, what is the role of visualization? First, it enables educators to visualize complex information. So they don't just have to simplify, they don't have to just use a subset of the data. They can use a representative set and filter it as they see fit. And it's web-based tools, so they don't have to download anything. It's easy accessible, and also for their students. In terms of students, they get engaged. How? Because they're presented with meaningful data patterns, because the visualization has been selected so to make those patterns that matter visible. You can maintain the richness of the concept, so again, you don't have to dilute it. And they get to see complex matter at an earlier stage in their education, so you can move them along much more quickly. You also encourage students to learn, to look for patterns, to investigate the data in an active way by interacting with the tools and the controls. Hopefully through that start to build an understanding of key concepts and hopefully also make learning more enjoyable. So data visualization has the potential in this particular context to transform education, and that can also apply to other domains. Finally, and I'm also looking at time, and I think I'm on schedule, when we have general data, large amounts of data, and there's many ways we may want to have to visualize the data to be able to extract those patterns that are of meaning, we have visual data analytics tools. So here, for example, we have Spotfire, and when you use these types of tools, you often create dashboards that are composed of multiple displays that are relevant to the task at hand. Here we're seeing a tree map and some network visualization, it looks like, or some specialized visualization. So here you're now coming into the territory where more specialized visualizations are being used. The displays are linked. And because you have experts who have something they really want to know about, and so they have the motivation to learn how to use it. Then we have examples from Tableau. Here, a dashboard with a map and linked line charts, and we can go through time. And another example from Tableau, and if you're seeing here at the top, we have again these highlights where we can sort of step through the data, and it will show the designer has decided this is how they want to frame it, similar to pages, similar to also the interface that I showed you for McGraw-Hill Data Viz tool. Oops, I didn't mean to click it. Let me come back. So, to bring it all together, we could sort of say at the tip of the data iceberg, or how to make it accessible, visible, we have infographics, where often you work with distilled data. Experts have gone over it, they have identified key patterns. A designer has thought about how to display it, and that can be a labor-intensive process. And often these displays, infographic displays, are static. They can be very effective at communicating quickly the highlights. If you want to allow users to go deeper into the data iceberg, so to speak, you start using interactive data visualization tools that build on the standard displays, and as need be, you will have variations or custom displays that are also included. These are being used by early adopters often and professionals. And then when the data gets so large that you can't humanly curate it, you'll start using visual data analytics methodology. You will have custom displays and data mining machine learning methods to identify subset in the multidimensional space that warrants further exploration. You may have a feedback loop between the visualization, looking at the patterns that are being discovered by the data mining, machine learning techniques, and then use interactions in the display to further drive or guide the machine learning methods. So in a way, this summarizes, sort of, hopefully gives you a sense where the different visualization approaches fit and how they relate to the complexity of the data that you're trying to make accessible and try to understand. So to conclude, no data pattern, no story, no engagement. Well-designed visualization draws viewers' attention to meaningful patterns in the data. Now there's time for questions.
Great. Thank you. Thank you, Anselm. This is Mark from ACRL and Choice, and I've been monitoring, if I can say that word, I've been monitoring the Q&A panel, and we've got several questions here. I would encourage folks to send in any additional questions that they may have. Looking through the questions that we've got, we got a couple questions very early on about the motion chart that you were demonstrating.
Yes.
And there were a few questions from Cuddy and Deborah and Kimberly about what software was used to put that together. So is that available from Google or
yes.
How? Yes.
So Google has decided, so Google has multiple data visualization tools and, you know, the standard candidates, and it also decided to make what Hans Rosling had developed under the name Gapminder available as a motion chart in Google. So it's a tool that's available for free. You put your data in the right format in a Google spreadsheet, and then you select the cells that you want to have visualized and pick the Google motion chart, and then you can visualize the data in that way. So it's a tool that's available for free. Again, the challenge there is coming up with having the right type of data that's suitable to be visualized as a Google motion chart. And if it does, I would say the Google chart is excellent at being able to make that temporal structure in the data, the trends, as well as the correlation patterns between the variables visible. And you don't need to only 2 of them. You can have 5 of them, 10 of them, 20 of them, and then you decide which ones you want to map to X and Y, to the horizontal and vertical axis, and that way move through the data space and explore it.
Great, thank you. Thank you. We've got a few more questions. Let me, we've got a question here from Shelley that says, this is a bit tangential, but I was thinking about keeping track of all the parts of my job. Has anyone used visualization elements to create a task tracking tool? And she suggests that the fisheye might be useful for something like that. Are there any visualizations specifically for tracking tasks and things like that that you know of?
Yes. I mean, I wouldn't come up with, right now I don't have one that sort of stands out, but yes, people have looked at all types of data and wondered or asked themselves, how would I visualize, let's say, my to-dos or things that are calendar-based? So there are different ways of visualizing calendar type of data, or, you know, using Gantt charts in terms of their dependencies between certain tasks and so on. Now, as somebody who has spent time, what I would call on the bleeding edge of a data visualization, meaning investing time to come up with new types of representations so that other types or certain types of relationships in the data can be made visible. There's lots of proposals, even implementations. The question is, are they being adopted or not? Do they really satisfy a burning need, all right? So to come to this question about, you know, your to-dos, I think there certainly are prototypes out there that are trying to address it. The question was there enough need in order to then have that integrated, let's say, into a certain tool like a Microsoft Outlook or not? And so, yes, so there are ways to do it.
Great.
So you can, let me just.
I'm sorry, didn't mean to cut you off. Please go ahead.
No, I just got an idea as I let go. The thing then to think about your notes is, you know, what are the aspects to it? There's a temporal aspect to it. There's a categorical aspect to it. Are those categories, could they be visualized in a hierarchy? So if you want to emphasize more that hierarchical structure, you might go to a tree map. If you're more interested in a temporal view, you might go in another type of representation. And so, yes, there's, I would say, there will be lots of examples. The question is, are they successful or are they truly useful?
That's great. And to give a paradigm sort of for thinking about how one might approach representing those tasks, that's very useful. Thank you. We've got another question from Abby. And Abby says, Is that black outline feature, I think in DataViz, to indicate the close proximity between dots, is that a visual clue in this program, or is it something, or is it considered a general indicator in dot plots?
All right. So it's when you create these visualizations, actually what's being attempted in the DataViz materials property tool is quite ambitious, I would say. And being able to both show what's selected and what's in range. And so you can use different visual strategy to communicate to the viewer these different states. So having black outlines is one way to draw emphasis because it creates contrast, and that way draws the eye. So it's not an uncommon strategy to show, let's say when you look at a button, whether it's selected, its border might be thickened, and then you might increase the difference in terms of the color difference or intensity difference between the background and the text that sits in the button. But it's not certainly in the sense universal. You know, that's how you have to do it.
Sure, sure. So it's a way to differentiate,
yes,
to call attention to those specific points. Great. We've got sort of a general question here from Bev, and I don't know exactly. Yeah. So I'll just throw it out there. From Bev, we've got a question that says, "How is curated content discoverable?" And I don't know. Do you have any thoughts on that?
You mean discoverable through the web using a search engine?
I'm not sure. If Bev, if you're still on the line and have a bit of clarification that you could offer us. But yeah, are there places on the web perhaps that are rich sources of curated content?
I mean, the OECD is, the World Bank is, Google has put together data sets. There's a whole movement in DataGov where data is being aggregated, maybe not necessarily cleaned, but at least available in raw form. There have also been places that have tried to become data portals, and similar to YouTube videos, that you would have data sets that you could find there, and then people could comment about it and talk about the quality of it or make sort of a review of it and score the data. So yes, there are places like that that you can find online. I think the entry point is through the search engines.
Sure. That makes sense. That makes sense.
I mean, and the other thing then also to say, and this relates to the whole concept of scraping, meaning that you may find data in a PDF or in reports or on a web page because you're formulating a query and then you get a table view of it, and then you would like to be able to use that. So there are tools out there that let you suck out the data, so to speak, scrape it out. There's issues in terms of legality. And if you look at, for example, if you want to, and I spent a part of my life building search visualization tools that were built on top of, let's say, what Google does. And so we needed to get our hands on the Google search results. And Google has made it progressively more difficult that you can scrape their data. And certain websites will monitor, you know, how often you knock on their door to see whether you're trying to do something you're not supposed to do.
Great, thank you. We've got more questions at this point than we can get to all of them in the time allotted. But I think maybe this one would be an interesting question to end on, and it comes from Cecilia. And Cecilia asks, do you have any suggestions or favorite data visualization programs or styles of data visualization? Anything that jumps to the top of your mind?
I mean, what I've been trying to sort of speak to is the standard displays are good. Mm-hmm. You start with those, all right? And so you can create some of them in Excel. They will not be interactive. You can create them using Google tools. It gives you quite a lot of functionality. I think what Excel, I could even say the love for or an appreciation for the motion chart, because I think it brings together some of the best features in a modern data visualization tool. But again, you need the right data to be able to make it sing, so to speak. There's Tableau that has a way that you can use their tools for free. There the catch is, and that sort of also comes back to the question, where do you find data? If you want to use the free tools, your data will be available to everybody, so they can download your visualization and get their hands on the data. So I think the other thing to keep in mind, I don't know if this is the right way, the right metaphor, the dog or the tail, which one wags what. At the core, at the essence of it, at the center of it is the data. That's what's valuable. And then you lay around it the visualization in order to make certain things visible to specific constituencies. It may be to experts, and they're more forgiving, more tolerant if it isn't as well designed. And then all the way to a general audience, and there you might go through different steps of how you simplify it all the way to an infographics. And so to bring back one place that I look to sort of see what's going on is what the newspapers are doing. So the example from The Guardian or examples from the New York Times or the Washington Post, where they are using visualizations to tell a story with the data. And what are they using in order to communicate it or to make it accessible? Also there's been one school of thought in data journalism is that making the data available for everybody so that they can then go through and do their own due diligence and see, do I get the same patterns that they are talking about if I put it in my visualization or I put it in Excel and quickly create some charts, so that we can validate or make sure that what's being said or inferred from the data is actually valid. Now,
right, well,
if people have questions, I don't know if you caught my email or you just search for my name, and you can send me further questions if you have them.
Great. Thank you. Thank you very much, Dr. Spoerri. It's been a very interesting and I think really fascinating presentation. I would remind folks that they can let us know how we did. They can take our survey. If they see the link there in the chat box, please, as you're signing off here, take a moment and provide us a little feedback on the presentation. And I'll remind folks, too, that we did record the program today, so be on the lookout tomorrow for that email with a link to the recording from ACRL and Choice. And I just want to say thank you to everybody who is out there listening in today. I hope you enjoyed the session, and I hope all of you have a wonderful rest of your day. Thanks very much.